Big O Tires can sell 10,230 Michelin RG tires per week nationally if the price is set at $85 per tire, but only 8,320 tires if the price is $105 each. Using a linear demand model, what is the price elasticity of demand for these tires at Big O Tires if the price is $110? So we know that this is the formula for the elasticity of demand, the absolute value of P over Q multiplied by the derivative of Q with respect to the price P. So now the first step, we need to find the equation of the demand. If you recall from the previous lecture, we saw the linear function y equal mx plus b. This is the slope-intercept form. Now, y is the q in this case. The slope m is still the same, but the x now becomes the price p. So we want to find the equation of demand q with respect to the price p. Okay, so the x now is the p value and the y now is the q value. Looking at the problem, we know that they can sell 10,230 tires per week if the price is set to be $85. So I know that I have $85, then I can sell 10,230, right? And let's just call this is my P1 and my Q1. And then they can only sell 8,320 if they had the price for 105. Higher price, the demand goes down. This is my P2 and Q2. So now I can find my slope very easy. The slope m is Q2. Remember, Q is now acting as y and P is acting as the x. So y2 minus y1 or Q2 minus Q1 over x2 minus x1 now is P2 minus P1. And this should be 8,320 minus Q1. Q1 is 10,230 divided by P2, 105 minus P1 is 85. And if you do that correctly, you should get negative 95.5 for the slope m. So now I can make a substitution here, and I get my Q is equal negative 95.5 P plus B. Now I can also use the one of the point. Maybe I can use this point here so that I can solve for the value of P of B. So my Q is 110,230. And it happens when my price is 85. Again, I'm using this point right here. I can call this is P and this is Q, right? And then plus B. And let's use the calculator. In this case, we have minus 95.5 multiplied by 85, and I can add this on both sides so to solve for B. So 10,230, right? And then I add 8,117.5. Then I get 18,347.5. 18,347.5. That is my B or the y-intercept. Now I can complete my equation. Q equal minus 95.5 P plus B 18,347.5. So that is my demand equation, linear equation. Now I need to find the QDP, right? That is the same thing as finding Q prime and taking the derivative of this term. That becomes minus 85.5, and this one a constant, so it becomes 0. And this is the DQDP with respect to the price P. Okay, so now I go back here. I plug in everything. When my price is equal to $110, that is what they want us to use. That is the P value. What happened to my Q? So when the price is equal 110, I can use this equation to solve for Q. Q is minus 95.5, multiply 110, and add 18347.5. And we can quickly do that and see what we get here. Minus 95.5, multiply 110, and we add to 18,347.5. That is 77842.5. That is my Q when my P is 110. So now I put it here 7842.5. And then I multiply by the derivative dQdP, which is right here. And that is negative 95.5. And now we can use a calculator to multiply together. Remember, this is the absolute value, so you don't need to worry about the negative value. It will become positive later. So we take 110, we multiply 95.5. I don't care about negative value because of the absolute value. Alright, and then I divide by 7842.5. And it gives me 1.34 if I round it to two decimal places. 1.34. Let's check the answer here. Yeah, it's around that. And the elasticity of demand, in this case 1.34, it is bigger than 1, right? So it is bigger than 1, so that is elastic. So the tires are elastic as this price. Elastic means if you increase a little bit about the price, then the demand will go down and you don't gain more money. Alright, and now they ask you what is the elasticity of demand. Oh, okay. What is the elasticity of demand for these tires at Big O Tires if the price is $90 instead of $110? So we will repeat the same process, but now we will use the $90 for the price. So I have P of 90, and then now I need to find Q. So Q is minus 95.5, and then 90, and plus the same thing again, 0.5, and we will multiply that, 95.5 multiply 90, and we add to 18,347.5. That is 9752.5. That is the Q. So the new elasticity of demand, the price now is 90, and then the new Q is 9752.5. DQDP still minus 95.5. So now let's see what do we get for the new elasticity of demand. Okay, so we take 90, right? 90, we divide by this number, right? 9 something, and then we multiply by 95.5. Again, I don't need to worry about the negative value because that will turn into positive. And I get 0.88 is my new elasticity of demand. This is less than 1, so it's inelastic. So let's check the answer. 0.88. It should be 0.88. It's right here, 0.88, and therefore it is inelastic. Next question, they ask you at what price is the maximum revenue per week achieved? So we need to find the revenue equation, right? Revenue again is equal to price multiplied the quantity. And I know that the price is P and the quantity. What is the formula for that? Remember we got the Q function is right here, minus 95.5 P plus 18347.5 minus 95.5 P plus 1A, I think 1A 347.5 347.5. That is my Q in terms of P, right? And then now I need to multiply it in, so minus 95.5 P squared, and then multiply that, I get 18347.5. And this is my revenue, right? I want to maximize the revenue. They ask you what should be the price. That's why we need to rewrite the revenue equation in terms of the price. So now I need to take the derivative, right, to find a critical value. So bring down 2 to minus 95.5. We can do a quick calculation here. Minus 95.5 multiply with 2. It should be minus 91, right? Directly from here. Minus 91, 191, 191, and then subtract 1 from P. We got the P to the first power, and this one a constant, it becomes 0, right? Oh, sorry, I forget the P. When I multiply P to here, it should be P. So it plus 18347.5 when we take the derivative. And then set it equal to 0. And then now you add 191p on both sides to isolate the p, so we can solve for the price. 191p, and to solve for p, we divide both sides by 191. So I get 18347.5 divided by 191, and that is $96 around that, to maximize the weekly revenue, right? And this is right here, $96. And they ask you, what is that maximum revenue per week? Okay, we have $96. So you want to find that maximum revenue, right? Remember this is the revenue equation right here before we take the derivative. So now we know that this is the price to maximize that R, and we want to find what is that actual R value, right? So we plug in 96 to the price P. So minus 95.5 and then 96 square plus this one here, 19347.5 multiplied by P, and P now is 96 because 96 is the one that maximizes everything for the revenue. So I used my calculator again. 96 square multiply minus 95.5, and then I add to 96 multiply 1847.5. Right, we just plug in the revenue equation and I get 881232. And you want to round it to the nearest 1,000, so you just round it down to 88,000. Sorry, 881 and then 000, because you want to round it to the nearest 1,000. So 881,000. Okay, because these three numbers, they are less than 500, so we just round it down to $881,000. All right, and the last questions: how many tires will be sold each week at that optimal price? So we know that the price of $96 is the optimal price, right? But at this price, how many tires? That means they ask you for the value of Q. What is the Q value when the price is $96? Remember the Q value of $96. So if you remember from the last page, we solved for the Q equation, right? The Q, which is right here. The Q equation is this one in terms of the price. Minus 95.5p minus 95.5p plus 18347.5. So let me write here again. It's actually right here. This is the, no, actually right here. This one right here, because this one is the Q, right? That is the equation for the Q. So Q is minus 95.5p plus 18347.5. So we just plug in 96 to the price to get the demand, right? How many tires? So we plug in 96 there plus 18347.5. And let's use the calculator to get the answer. Minus, this is 95.5. So minus 95.5 multiply 96. And we add to 18347.5. That is, check the answer. We want to round it to the nearest 10 tires, right? 10 tires. So 91, 89, right? We want to round to the nearest 10 tires. So 89.5, we round to 80. Round up, right? Because 80, this is bigger than 5. So we round to 80. So 9180. And that is how you answer this question. It's a long question. It has 7 small parts here.